Hello, this is Algebra 2, topic 2-2, on solving log equations. So, last time in 2-1 we talked about how you can expand and condense logarithms. Today we're going to actually need to know what logarithms are so that we can solve them. Well, logarithms, log of the base of the answer equals the exponent. Okay? I'm going to say b is the base, e is the exponent, and a is the answer. So I'm using this to try to rearrange the logs where it makes sense. So I've got my log base 7 of x equals 2. So that means that 7 squared equals x. So my base, my exponent, and my answer. And well, 7 squared is real simple. It's 49. So x equals 49. Let's go ahead and move on to example number 2. It's a little bit more complicated. Here we're saying that our base is x, our exponent is 3/2, and this equals 27. Well, I can rewrite the exponent 3/2 as the square root of x cubed equals 27. Then I square both sides so I can get rid of the square root. And I get that x to the third equals 729. Well, now I need to factor 729 to figure out what x cubed is. Well, I'm looking at this, and I think I can divide it by 9. So if I do 729 divided by 9, I get 81. And another 81 is 9 squared. So I have 3 9s. So x must equal 9. Moving on to example number 3. Our base, again, is the x. We're raised to the 0 power, and we're saying that equals 2. Well, this is impossible, because x to the 0 always equals 1. So we have no solution. And on down to example number 4. Our base is 2, our exponent is x, and we're calling this equal to 64. Well, 2 to the first is 2. 2 squared is 4. 2 cubed would be 4 times 2 is 8. 2 to the fourth, 8 times 2 is 16. 2 to the fifth, 16 times 2 is 32. 2 to the sixth, 32 times 2 is 64. So we get that x must equal 6. Let's go ahead and move on to example number 5. Well, our base here is 2. Our exponent is 4. And this equals x minus 9. Well, 2 to the fourth, you can look on what we just did, but it equals 16. That equals x minus 9. So we have 16 equals x minus 9. If I add 9 to both sides, I get that 25 equals x. Simple enough. Now for 6, 7, and 8, we're going to have to condense our logarithm because we want one log expression on one side and one term on the other, if we can. But we definitely have to have just a single log expression, and that needs to be the only thing on that side. So I'm looking over here, and I can subtract 15 from both sides, and I get that 2 log base 2 of x equals 10. Well, 2 log 2 of x is the same as log base 2 of x squared, and that equals 10. Well, that means 2 to the 10th equals x squared. Well, 2 to the 10th, use my calculator, and I get that 1024 equals x squared. And if I take the square root of 1024, I get that 32 equals x. Go ahead and move on to number 7. Well, I need to get all of my logs to one side, so I'm going to plus that log. And then I'm going to go ahead and add 2. So these statements will cancel out, and these statements will cancel out, giving me that the log base 8 of 4 plus the log base 8 of x equals 2. Well, I can combine these logs because of this addition makes it one log statement of multiplication. So now I've got this simple. 8 is my base, 2 is my exponent, and that equals 4x. Well, 8 squared is 64 equals 4x. We divide both sides by 4, and 64 divided by 4 is 16. And now for our last example, again we want to move our logs to one side, our regular numbers to the other. So I'm going to subtract log base 4 of x and add 1. That makes those cancel and those cancel, giving me the log base 4 of 8 minus the log base 4 of x equal to 1. Minus means divide, so the log base 4 of 8 over x equals 1. 4 is my base, 1 is my exponent, 8 over x is my answer. Well, 4 the first is just 4, so 4 equals 8 over x. Multiply both sides by x. 4x equals 8. Divide both sides by 4, and we get that x equals 2. And so this was this example. Again, what you want to do is you want to make sure that you get all of your logs to one side, condense your logarithms, and then set it up to solve. Good luck on your assignment. Have a good day.